Hello and good day, everyone. My name is Cathy Sham. I'm currently serving at NASA as its Lunar and Human Spaceflight Spectrum Manager. I will also serve as the chair of the Lunar Martian Spectrum Group in the Space Frequency Coordination Group. Additionally, I have served as the ITUR Working Party 7B chair during the last study cycle. Today, my talk is about Cislunar Spectrum Planning to protect science and enable exploration. First, I wanted to give you a summary of what is the outcome of World Radio Conference 2023. During the conference, there were discussions about future lunar missions and the need for additional radio frequency spectrum to support lunar surface operations and those operations that would occur in the lunar vicinity, considering the talent and time and money that has been spent on planning a lunar mission and studies that have been performed over the last several years. These reference missions and its concept of operation have shown us that a lunar capability to have PNT data to deliver positioning and time data to spacecraft, and also to transfer its data from the surface to orbit and a relay system to take it back to the Earth is ever more important. These studies also show that in order to enable the capabilities that it's necessary and the missions that we are planning, ever more complex mission in the lunar vicinity, that distinct frequencies for use for in situ operations is important and critical because of interference scenarios that we have identified if they were to use the same frequencies as those frequencies that are typically used for long-range communications between the moon and the Earth. WRC 23 agreed. For WRC 2027, we now have a lunar communications agenda item. This agenda item would include studies that will be performed over the next 3.5 years on specific frequencies that is identified in Resolution 680. In Resolution 680, it calls out specific conditions and sharing studies that will be necessary to perform the studies and conclude and make a recommendation for administrations that will be participating in World Radio Conference 2027 to make a decision on possible new frequency allocations or modify frequency allocations under the Space Research Service space-to-space allocation. Within this agenda item that studies will be conducted, it will also include frequencies that will be provided and identified and set aside for the capability of providing in situ positioning and timing data to lunar surface systems and lunar orbiting systems. This study has begun last month, and Working Party 7B within the ITUR is the responsible party that will be working with other competent working parties within the ITUR to complete the studies and develop the recommendations that will inform administrations that will be participating in World Radio Conference 2027. The frequency ranges within the 2400 to 2690 megahertz range would be a part of the frequency bands under study, and the PNT service is currently within that range, which will be studied to determine whether or not there are any compatibility issues. If there are, then we would develop mitigation approaches to ensure compatibility with existing services that are operating in the same frequency range. I mentioned the Space Frequency Coordination Group previously, and the Lunar Martian Spectrum Group. The SFCG's history began over 40 years ago with a few space agencies coordinating scientific missions that would operate in the same frequency band. The SFCG is concerned with the effective use and management of radio frequency bands that are already allocated by the radio regulation of the ITU for space science applications. And this activity within the Space Frequency Coordination Group and its member agencies is to discuss and determine means which at the agency level could be affected to ensure that our missions are compatible and able to achieve the goal of the mission overall. And as you can see in this slide, that technical studies are conducted by members of the SFCG to ensure that there are no conflict between missions as we plan and develop our missions. If necessary, between the agencies of the SFCG, we would even develop and commit ourselves to making sure that we design the system in a way that will be compatible. So that may mean necessarily that we have to perform and actually include more stringent requirements imposed on our own systems. And these principles of the SFCG have continued to serve our civil space agency missions very well. And additionally, our membership are also encouraged to work within their own administrations to facilitate pre-coordination activities with other entities who are flying space missions in order to further ensure that all the space missions globally understand what needs to be done to perform our missions and share the frequency within the confines of the radio regulation. Through these means, we have now expanded the SFCG to many, many different space agencies around the globe in all three regions of the ITU, and continue to facilitate not only our own missions, but missions that we are partnering with other space agencies or other industry partners. One of the very important things about lunar exploration and lunar missions is to make sure that we understand in that region where we're doing mission, are there special conditions that we have to protect? One of the most important things that we have to remember and we realize is the protection of the shielded zone of the moon, which is the side of the moon that is not currently visible to the Earth. And it's immune or protected basically from the radio emissions from Earth and from the Earth orbit. This area is needing to be preserved for unique science that cannot be done on Earth currently or from the Earth orbit. The ITU actually have many years ago established and agreed on an article to protect the shielded zone of the moon from intentional radio emissions. And there's also recommendations that it's in place in the ITU to protect certain frequencies for radio astronomy measurements when they operate in the shielded zone of the moon. And that is actually one of the very important aspects of the selection that we have made, and it very intentionally, for other lunar systems that in the future will be going to the region and the agenda item where we're going to study new spectrum for future lunar missions. On this slide, I wanted to show you that the diagram that contains frequencies which the SFCG have studied and recommend as options for lunar positioning, navigation, and timing service. The 2.4835 and 2.5 gigahertz frequency range is the range which SFCG has membership, have preliminary determined that it is suitable for this in situ service, which is different than the L-band service that we have for Earth-based GNSS service. And this goes back to what I had mentioned previously, that preliminary studies by space agencies in different countries have determined that in situ frequencies for services around the moon would need to be different than those that are currently used around Earth and on Earth to prevent and mitigate interference due to the geometry and the power differential. So in this case, the 2.4835 to 2.5 gigahertz range is the recommended frequency which we will study in the ITU for a decision at World Radio Conference 2027. There's also the 5 gigahertz range that you see on this slide, which is currently under consideration to determine whether or not it may be a suitable band in the future to supply the necessary bandwidth for additional capabilities and service in the lunar vicinity. Aligning with the Artemis Accords vision and a multinational industry government compromise of missions that are going to the lunar vicinity, NASA have stood up a lunar spectrum management role, which currently I'm fulfilling that role. And as the lunar spectrum manager, in addition to facilitating coordination between the different agencies and partners domestically and internationally, some of the more important aspects from a technical coordination perspective, you will see on this slide, on the right side of the slide, that Lunar Spectrum Manager is also one to provide information on available spectrum and applicable spectrum policies and constraints to new missions that are in planning phase, so that they could take that information and incorporate into their design and their specifications as early as possible to ensure that spectrum is taken into consideration as part of the planning process rather than an afterthought. The second thing that's very important is the spectrum management team, the Lunar Spectrum Management Team, also assists in frequency selection and sharing studies so that we could provide possible mitigation approaches and recommendations for the mission to consider as they continue to advance their design into implementation. And in this process, the Lunar Spectrum Manager will also facilitate discussions and conversations with the other parties involved in this interference scenario to come up with an agreement and an approach so that interference can be mitigated and that all the missions and all parties involved can actually do their mission with the minimum amount of constraints. And lastly, I wanted to share with you some information about the Lunar Spectrum Management Portal that has been developed to facilitate this coordination process. And the portal provides capabilities to receive mission coordination data and also manage the analysis and review process flow, provide resources also to missions that are involved in the pre-coordination. If you are interested, please contact the portal data manager. The information is on the slide so that you could reach out and directly and get access to this portal. And finally, I really want to thank you very much for this opportunity to provide the status on the cislunar planning activities that has been ongoing within NASA, within the Space Frequency Coordination Group, and our partners, and to be able to give me this opportunity to also explain the relevance of what we've been doing to the GNSS community.